Now we will analyze the motion of a motorcyclist inside a circular cage. Normally this motorcyclist who is moving in a circular cage maintains certain speed. So in a circus you may find this type of motorcyclist moving in a circular cage. See, at the top of the cage, what are the force acting on the cyclist? One is the reaction of this cage on the motorcyclist, that is R, and second one is mass. Because of its mass, the gravitational force acting on it, that is the mg. So the net force acting on this motorcyclist at the top of the cage is R plus mg. This is the net force towards the center. This is nothing but the centripetal force, mv square by r, where r is the radius of this cage. Now reaction equal to mv square by r minus mg. Now as long as reaction is positive or up to 0, this is the limiting case, this motorcyclist will not lose contact at the top. But if the reaction is negative, then this motorcyclist will lose contact. So for the reaction to be positive, mv square by r should be greater than mg, then only this term should be greater than mg, then only reaction is positive. So therefore v should be greater than root over rg. So in order to move safely inside this circular cage, first of all this motorcyclist will calculate this critical speed what he should maintain. This is based on the radius of the circular cage. If you have seen these sports in circus, you see first of all they starts moving in a lower circle. Once they gear up and maintain this speed, then only they go in the vertical loop. So that for safe looping inside this circular cage, speed to be maintained is root over rg. Say if the radius of the circle is set 10 meter, say acceleration due to gravity is 9.8, or we can say for the time being, for example, say it is 10 meter per second square. Approximation is done here. So the velocity to be maintained is root over rg, that is it should be greater than 10 meter per second. Roughly the motorcyclist will maintain a speed 10 meter per second, then only he will start looping in a vertical direction.